This is IR 1.3. So shall I dictate the problem? A car starts rectilinearly. A car starts rectilinearly, starts moving in a straight line. So rectilinearly is another word. That's all. A car starts rectilinearly, first with an acceleration A is equal to 5 meters per second square. Then uniformly, and finally decelerating at the same rate A. Decelerating at the same rate A. A car starts rectilinearly first with acceleration A is equal to 5 meters per second square. Then uniformly and finally decelerating at the same rate A and comes to a stop, full stop. The total time of motion equal to T is equal to 25 seconds. Capital T is equal to 25 seconds. The average velocity during the whole time is equal to 72 kilometers per hour. How long does the car move uniformly? How long does the car move uniformly? Once again, I will quickly read it. Okay, a car starts rectilinearly first with acceleration A is equal to 5 meters per second square, then uniformly and finally decelerating at the same rate A, comes to a stop. The total time of motion equal to T is equal to 25 seconds. The average velocity during that time is equal to 72 kilometers per hour. How long does the car move uniformly? So, what was our question? Our question was, first let us visualize the question. Okay, the question is that initially, okay, it was starting, let us say at some point, I am going to write a VT graph for this. So that will give a very good understanding of what is happening, because velocity is changing. Okay, let me see. Okay, so initially it actually increases its velocity from 0 to something. Okay, at a rate of 5 meters per second square. Okay, that is the acceleration. And then it goes for a constant uniform velocity for some time. We don't know how long. And then it comes back with the same, it decelerates with the same velocity minus 5 meters per second square, that's all. And becomes 0 here. Okay. And we have been told that this whole time is 25 seconds. Correct? And we are also told that the average velocity is how much? 72 kilometers per hour. I will convert it into meters per second, which is 72 into 1000 divided by 60 into 60, where 0, 0 will go, 0, 0 will go, 6 ones are 6 twos are, 6 twos are, 2 tens are, 20 meter per second. Okay. So you have to always remember that 36 kilometers per hour whenever they give you, which is 10 meters per second. 72 kilometers per hour, 20 meters per second. 54 kilometers per hour, 15 meters per second. Such things you have to remember, okay, when you want to do things fast, because that is normally given in any books and any competitions everywhere. Okay. So make sure that you remember those. Okay. Now I'm going to basically show you how to go about further. Okay, you got V. Okay. So now we will now see whether we can do a what is our statement on, let us say, average velocity. Average velocity simply means what? Total displacement by total time. So what is the total displacement? Have they given you? This is actually this distance plus this distance plus this distance. That is okay. So what is this distance? No, what is this distance? This distance simply this.
Average velocity is equal to total distance by total time.
Tushar, actually I can't see him, but though he is here, his video is not coming.
So average velocity into time is given, and average velocity is also given.
You're right, correct. No, that way you cannot kind of find out the total this one. You could calculate like that. Okay, total you can calculate, but that would not give. If you set up such an equation, we cannot get any value of whatever we want here. Okay, look at this. This value, velocity, let us say, the velocity that it has reached, I will call it as, let us say, V1. Okay, so this velocity is V1. We want to find out what? We want to find out how long that V1 was there. This time. This time. That is what we want to find out. Okay. So to be able to do that, what is the total? We can. Okay. What is the total distance traveled during this time? Can somebody tell me quickly? What is the total distance traveled? What was the total distance traveled during this much time? How will you calculate? What is the total distance traveled during this much time?
I did it by taking.
So let us say this time as, I will take this time as capital T. Okay. So I will take this as capital T, this also as capital T, and I am assuming that this T and this T are same. Do you agree? They are same because same rate you are using. So going up, we are going down. Okay. So this is T. So now this T plus this value is nothing but 25. So what we have to find out, and our aim is actually, what we want to find out, 25 minus 2t. This is what we have to find out. Correct? This is our aim. Total is 25 minus 2t we have to calculate. That is our aim. So if we calculate t, we could actually calculate 25 minus 2t later. So I will write this area as half into 5 into t square. Half at square, ut plus half at square. Okay. This is area. Uniform acceleration. S is equal to ut plus half at square, u is equal to 0. You have to use things that you already know. You cannot forget them. Okay. So once you use that, then everything is together. Whatever you are learning from 6th standard to 12th standard, all of them to be always used. Nothing can be forgotten. Okay. So here what is that? V1. This is V1 into this time, which is 25 minus 2t. Correct? Plus. What is plus? How much is this one? This distance. How much distance this is? This distance and this distance, would it be same? Do you think? Correct, correct. But this will be same because it is the area under this curve. Okay. That will also be equal to half into 5 into t square. Finally, if you calculate, okay, it will come as, there will be values for u now, ut minus half at square, but it will turn out to be half into 5 into t square because that is same as this area. Area under the curve gives you the distance traveled. This whole divided by 25. Correct? Okay. And that is given as for you 20 meter per second. This is 20. Okay. Now, what is to see? Look at this equation. We have set up one equation. The problem with this equation is this has two unknowns. Does it have two unknowns? How many unknowns are there? Correct. So we will remove one unknown. Okay. So V1 is this value, which is nothing but V is equal to U plus AD. That formula also is the first formula that we learned. Okay. So V1, which is going here, is nothing but the last final velocity of this guy. This, when you going from 0 to this, final velocity is V1 for this area. Okay. So V1 is nothing but U is 0. AT means 5 into t. Okay. In the place of V1, you put 5t. So solve for t. Half into 5 into t square plus half into 5 into t square is 5 into t square, like that. Five t square plus 25 into 5. Okay, 25 into 5 t, 25 into 5t. Okay, minus 5 into 2, which is 10t square. Okay, is equal to 20 into 25. So please watch why. Well, I will never do multiplications and divisions. I just keep them as it is. Okay. No, this one I multiplied here, and the top one I kept as it is. This half of 5t square and another half 5t square is one full 5t square. Okay. And then V1 I will put 5t here. 5t into 25. 5t into 25 I wrote as it is. Minus V1 into 2t. V1 is 5t. 5t into 2t is 10t square. Okay. So this is nothing but 5t square minus 25 into 5 t into t. Okay. Plus 20 into 25 is equal to 0. Okay, I just 5t square minus 5t square is minus 5t square. Okay, I took the minus 5t square, that's why I make plus 5t square. Okay, now I will divide everywhere by 5. T square minus 25t plus this one we written as 20 into 5 is equal to 0. So now what I will do is basically we have to take two values now, minus 20 and minus 5. Okay, we can take these two values. Okay, if you multiply minus 20 into minus 5, you will get 20 into 5. If you add minus 20 and minus 5, you will get minus 25. Okay, so then it will be nothing but finally t minus 20 into t minus 5 is equal to 0. So t can be equal to either 20 or 5. Okay, so we will claim that t cannot be 20. Because total t itself is 25, and if you take t as 20, this side 20, the other side 20, total 40, it will exceed this. So we cannot take 20. That is not suitable answer. The suitable answer is 5. Okay, so t is 5. T is equal to 5. Therefore, our final answer is 25 minus 2t, which is nothing but 15 seconds.